Bangladesh, and I have completed my post-graduation business background. Thank you.
I'm sorry, what you did to postgraduate what?
Sorry, can you tell me again, please?
No, I didn't get you. You say you finished postgraduate something.
Yeah, I have finished post-graduation from Dhaka University, and my major was quantitative marketing. It was a business administration.
Okay. That sounds great.
Thank you.
Okay. Yeah, so brother,
Hello. There was some problem at my end. Okay.
Yeah, I got it. So let me tell you where we are.
Yeah.
So they have some knowledge on Python. They finished with another instructor. And then I have started SQL. Before, I was thinking before starting Hadoop, let's start SQL first, so they will understand Hive query better.
Yes.
And with that things, I took 2 or 3 classes on SQL, and they have very early stage of knowledge, meaning how to declare a table or how to create a database, which one you are using, inserting some data on it. So that's all. So you can think of it, they're almost new or just getting familiar with it. And since you are a SQL master, so yeah, think in your way, so they can be benefited from your experience. Okay?
Yes, sure.
And yeah, by this time they also downloaded MySQL and what else? Sublime Text. So that's the tools they have. Yeah, and that's the technology they are familiar with. So you can be comfortable with them now. Okay.
Okay.
All right.
So yeah. So yesterday I talked with Adam and Rapani, and they actually gave me that we need to teach them SQL also and big data also. So what I'm planning is that we have 3 sessions in a week. So 2 sessions I'll take of big data, and 1 session I'll take of SQL. Okay, don't worry, till we will reach Hive, which is basically a query tool for Hadoop ecosystem. So till we reach Hive, we will finish our SQL. You will be comfortable with SQL. Okay, we'll start today with just for IT background people, we just jogging up the memory, and for non-IT, we will know what data is, what big data is. Okay, the sources we have, and what are the challenges we face with the thing that we are doing with big data. Because every technology comes, but there are challenges regarding that. And after this is the first half. Okay, so every day, like every session, not every day, the class is of like 2 hours. Okay, so first half we'll discuss about data, big data, their problems and their solutions, how Hadoop came in picture. In the second half, we'll discuss about virtualization and why use Linux. Okay, big data is not performed on Windows. Okay, in companies you'll be working on Linux environment. So why do we need to use Linux, not Windows? Okay, so let's start. First, let me share my screen. Is my screen visible to everyone?
Yeah.
Yeah, good. So the first question comes, what is data? So can anyone tell me what is data? See guys, you will have to interact with me, okay? Unmute yourself, talk to me, and then mute yourself again.
I don't have any idea, but
Okay, so data is facts and figures. Facts and figures means like if I write 12, this is data. But what does this mean? Okay, is it an age, a roll number, or an employee ID? We don't know. But this is something that we have. Now, if I say age equal to 12, I've assigned an attribute we call age equal to 12. That means now we know what 12 stands for. 12 is age. So this just became information. Okay, data is raw facts and figures. That's what. And when we talk about data, we have to talk about the size also, because we have to distinguish data, right? Like I have this much data with me. I need to process this much data. So comes in picture data hierarchy. 8 bits is equal to 1 byte. Okay, these are important things to know. Okay, because when we talk about data, we are actually talking about MBs, GBs, TBs. So this is kind of important. Is equal to 1 kilo. Okay, everything goes off in 1024. 1024 kilobyte will be equal to 1 megabyte. 1024 megabyte will be equal to 1 gigabyte. 1024 gigabyte is equal to 1 terabyte. 1024 terabyte is equal to 1 petabyte. 1024 petabyte is equal to 1 exabyte. And then we have Yoto, Zonto, a lot of things. But currently we are in a range of this. Okay, most of the companies are working in this area, from GBs, TBs, and petabytes. Okay. Some of the companies, like you can say Google, Microsoft, and these have reached this exabyte state already. They have such a huge amount of data. Okay, but mostly we are dealing with gigabytes and terabytes, and some of the companies with petabytes. Okay, so right now I'm working in a company, and the module that I'm assigned to is having one table of 28 terabytes. Okay, 28 terabytes of one table. So they have, if I talk about the whole company data, there might be 1, 2, or 20 petabytes. I also don't know. So this is a huge amount of data. Now the question comes about big data. Okay, what is big data? What contributes? What makes data? Like we have all the facts and figures, and we have you have also seen in MySQL tables. So you have seen columns and rows. We have that kind of data. Okay, but what amount of data will be called big data? So there are basically two factors that makes a data big data: storage and processing. here. Okay. Storage. Now the thing is that if I'm able to store, like for example, we have our computers. Okay, so we have some of you might have 1 terabyte of hard disk. Okay, so if I have a data of 20 terabytes, how am I gonna store on my system? Not possible, right? So this constitutes,
Yeah, Brother Hasnain,
yes,
can you please make the font little bigger?
yeah, sure,
Yeah.
Thank you.
Okay.
better.
Yeah.
Okay, yeah. So the storage problem comes when we have more data than we can store in a single system. Now we can do one thing, that we can get another 10 TB of terabytes, 10 TB of hard disk, and we can keep on increasing the amount of hard disk in one system. Yeah, that's possible, right? Not problem. But then, what if we have to process that data? We have to get something out of the data. For example, we have a sales data, and we have a sales data of past 10 years, constituting terabyte of data. Now, if we want to take out the highest sale of any particular year in those 10 years, then how will we process 20 terabytes of data with a single machine? How long will it take? Days, maybe months. So we cannot rely on one machine for this. So there comes a problem of processing. There's a problem of storage, and when a problem of storage, let's say we scale it and we add the hard disk and the SSDs and everything, but then we have only one processing unit, one CPU. So the problem is that the processing of data will take a lot of time. So based on these two problems, we constitute that a data and amount of data that can't be processed by a single machine efficiently will constitute big data. Okay, clear enough? Yes, no?
Yes.
Yeah, good. So regarding this, there are four V's of big data. If you might have actually explored big data anytime in your life, you would have come across, this is a common term that comes, V's of big data. First is volume. As we said, there's storage. Too big to handle. Okay. So second comes velocity. Right now, the data generated from our mobile phones. How much data do you think we have? The data generated in Facebook, it's like above 110 terabytes per hour. Per hour. So the velocity is really high. So with that velocity, we have to give them results also quickly. So the thing is, at that amount of time, the speed of the data is really high. So the storage has to be efficient to store that fast coming data. Plus, the processing should be efficient so that the data is processed and the results are given as fast as possible. Okay. Too fast to process. Okay. Now comes variety. Variety. What do you mean by variety? Different kinds of data. Now, how we define the kinds of data? So, data is basically defined in three kinds. First is structured, second, semi-structured, and third is unstructured. Everyone has started MySQL, right? So in MySQL we have, in SQL, any SQL, MySQL, PostgreSQL, we have structured data. What do you mean by structured data? Structured data means that everything has been assigned a data type of, like, this is an integer, this will be a number, this will be a name, so this will be a string, this is a salary, so it can be a float or an integer. So everything, every attribute has its name and a data type. So the thing is that this has every single data point that we have has a predefined structure with it. Then comes semi-structured data. So semi-structured data is this, right? This is basically a JSON. What is JSON? And we'll come to know. Okay, don't worry about it. Don't worry about the jargons right now. Right now we have to focus on what is this. So here, by looking at this, we can say that okay, this is number, this is also number, this is a name, so this is a string. But the thing is, computer, if we don't define these data types, okay, it will consider each and every one of them as a string only. That's how programming is designed. Okay, so this is semi-structured. It has a structure itself, but it's not completely defined because there are no data types given here. And then comes unstructured data. If I write this number, so what do you mean by this number? Is it an age, as I said earlier? Is it an employee ID? Is it a roll number? Hussein, who is then? He's an employee or a student? Who knows? What is 5,000 stands for? Is it his fees or salary or whatever it is? No one knows. Okay, so this data from which we actually cannot make out anything. We can't make out anything, so how can we expect the computer to make it out? So this kind of data is called what? Unstructured data. Okay, as we have these three varieties of data, we have to process them. So the challenge is, with structured data, okay, we can make SQL queries and we can get our results. But then again, there is a problem of processing, because SQL, the traditional RDBMS like the MySQL, PostgreSQL, when it comes to big data of TBs, 200 TBs, or like 20 TBs, these queries are not efficient. So here in structured data also, if we use the traditional database systems, then we have a problem. Semi-structured data has the same problem. Okay, we have an understanding of this, but the processing is done with NoSQL databases. Now, what is NoSQL databases? The databases that don't store the documents in form of tables, but in form of they don't store data in form of tables, columns, and rows, but in form of documents. Okay, so you can say this is a particular record, a document in which document name is defined and documents all the attributes are defined. So in semi-structured data, there's a problem that we have to actually tell each and every data, tell the computer about each and every data point. Okay, but this processing of this is easier than processing this. No SQLs are faster than SQL. Okay, and then comes the last one. This is unstructured data. So in today's world, 80% of the data is unstructured only. Only 20% of data is structured. So it becomes, because see, we see Twitter. Okay, there are people who are liking some photographs. Okay, they are commenting on things. So these are not structured, right? How can you structure a like, or how can you structure a comment? Okay, we have to make sense from the patterns of the comments that comes. If we want to know that what a sentiment of a person is, how are we going to do that? We don't have any structure of a comment, right? So that is unstructured data. Right now I gave three fields here, but this is a single line. Okay, for me, I am able to separate it with comma, but I have to tell the computer to separate this with comma. Okay, plus I have to tell the computer that this is a number, this is an ID, this is a string, this is a name, this is a number, this is a salary. So after I give all these, and this is called a schema, when we define the data type and the name of a field, we define schema of the whole record. Okay, so the challenge here is the variety of data. We had velocity, we had variety, and the last is veracity. Now what is veracity? It is quality of data. Now what do you mean by quality of data? For example, let's say that I posted something, okay, and there are people who are close to me. Even though they didn't like the post, out of obligation, they gave me a like. Okay, because they're friends with me and they think that, yeah, I'll feel bad if they don't. So can you trust that kind of data? Can you trust that like? So the quality of data is also important. Okay, knowing what data to include in the result for obtaining a particular, for solving a particular business problem, is as important as solving the problem itself. Okay, so we have the 4 V's of big data. Now, as we said that everything we have defined, now there is a challenge. Okay, the volume is too big. So earlier, in the earlier 1920s, 1940s, people used to make what? Notes, files. There was a file system, but a physical file system, which was too difficult to maintain, right? Sorry, excuse me. Which was too difficult to maintain. Why? Because if you had to search it, you'd have to manually go to a physical place, and then you have to open a drawer, you have to get the files out, you have to search from them. So it was not an efficient way of dealing with things. So what we did is that we came up with a solution for that, and that is called database management system. Sorry, where is that hint? It came with database management system. What is database management system? As we've been studying MySQL, you would have come with this DBMS. So we segregate everything into a database in which database in which we define schemas, in which we define tables, and each table is made in calls and rows. So we are giving a structure to our data, right? So this is a database management system. This is how we make a database management system. Now, if I have a sales data, okay, and I have a products data, okay, I have a database of sales, I have a database of products. Now I want to know that how many products are there, how many products were sold in the last month, and how many products are left. How can I know that? Because like the database of product is different and the database of sales is different. So how can I know that if I have to drive an insight or I have to get a result of how many stock is left with me without creating a relation between product and sales? There's no way that I know that how many products do I have left. So we are defining relationships between different databases. Okay, and that's how the concept of relational database management system came. Okay, today is the first class, so I'm going through these things because of an orientation, and people from non-technical background get the idea of what data engineering and SQL and how the data came in, because having a solid background will make things easier when we actually get into the technical words or jargons, as we call it. So after database management system, DBMS, RDBMS came, which is relational database management system. We defined relations between things. Okay, when you might have, or when we'll talk about SQL, when we'll talk about joining tables, we would need a relation from which we can join. Okay, so this is how relational database management system came. So this was good for our storage point of view. See, now the thing is, as the data got bigger and bigger, okay, relational database management system also failed. Why does relational management system came? Because we needed relations between different databases. So after RDBMS, what happened is that data got too large to handle for RDBMS, because the queries that we write became too slow. So to deal with that, the concept of data warehouse came. What is data warehouse? Forget this on-premise. What is data warehouse? Data warehouse helps to store data and process data more efficiently than relational database management system.
মুসলিম হুসাইন ইন্ডিয়া থেকে
Okay, the
না
thing
না
is
চালাই নিচ্ছে
that the data can come from a lot of sources, like from devices also, or from any, basically, uh, you can say that a pharmacy is there, okay, and there's a counter, and the data is coming from the system that they have designed. Okay, the data may come from flat files. Flat files is nothing but your text files. For example, I am writing this. Okay, this is a text file. Okay, and there might be different systems which is giving data. So what data warehouse does is this. What it does is that it has its data. Okay, now with the help of relations that it makes, relations that we define, it creates a summary of that data. So the thing is that whenever we, like for example, we have to find total records of these many years, the max profit of each and every month, the max sales of each and every month. So these all comes in summary of data. So it creates we can create a summary of data in the warehouse. Okay, and this is metadata. Metadata is nothing but data about data. What do you mean by data about data, right? So data about data means that we have a table, right? We have created a table here. Okay, now what is employee? It is a table. Okay, what is ID? It is an integer. So this is basically metadata of each and everything, that when I enter that insert into EMP values. So when I'm entering this data in this table, okay, so what am I doing is I am putting the data inside it. But this basically is the metadata, and this is the data we have stored. We have stored a record of 3 fields, but what are those 3 fields? Those fields are ID and it has a type integer, name and it has a type string, salary and it has a type float. So the thing is that all these 3 things data has a metadata associated with it. So it segregates the metadata, it segregates the raw data. We can create a summary of this. So a warehouse performs
তোমার আইডি
queries
বলছিল
more efficiently. So the problem that we had
তোমার
of
আইডি বললাম
storage is solved with the warehouse, plus processing is better in warehouses. So that's how the concept of data warehouse came, because we needed something to process the data better than RDBMS. Now what is this on-premise? On-premise means that there is a company. Okay, it has a particular server room in which all the hard disks and processing like processing units and everything is kept. So that becomes on-premise. Okay, so there are different kinds of data warehouses that we have. There we know SQL Server, that is from Microsoft. This is Netezza. Okay, IBM came out with its own data warehouse, DB2. Then we have this Teradata. But there was a problem. The problem was that these also had a limitation, because the data from terabytes got into petabytes. Okay, so when the data, let's say, generally these can't deal with petabytes. Petabytes is not their cup of tea. Okay, in terabytes also, if the data is less than 200 terabytes, we can use Netezza DB2 Teradata. It's okay. If the data exceeds from 200 terabytes, then the problem comes. Okay, because we cannot actually process the data faster and get the results as and when we want if the data has exceeded 200 terabytes. And Facebook is generating data of what? 110 terabytes per hour. So how can you expect a data warehouse to deal with a data as large as Facebook? So if we talk about Facebook, if Facebook started using DB2, what will happen? You would send a request to someone and he might get it after 5 days. So Facebook had to come up with something that could process its data faster. Okay, so that people get the friend requests and suggestions and everything that we do on Facebook. You post something, the post is gone worldwide. It cannot happen if we start using the data in traditional data warehouses like Netezza and DB2 and Teradata and stuff. Okay, so Facebook's data had to be on something that is more efficient in processing, and that's how Hadoop came in picture. Okay, okay, we learn about the history of the Hadoop because it is really important. Okay, to know how and who made Hadoop, how Hadoop came in picture. Okay, and why is Hadoop so popular? Okay, so then when the on-premise data warehouses actually reached their limitations, we had a distributed system was created known as Hadoop. So Hadoop made a problem, that is storage and processing, faster, better efficiently storing data, terabytes of data, and processing data faster than data warehouses and RDBMS. But the thing is that for maintaining each and every these things, okay, we have to create an infrastructure. Okay, we have to create servers, we have to create processing units, we have to hire employees to take care of their servers, we have to design so that the servers are efficiently connected to each other and the data is flowing from one point to another point seamlessly. That is also a problem itself, because what if today my company's data is 200 terabytes, let's say, but tomorrow my company data became 20 petabyte. So I have to create a whole new infrastructure for that. So that problem was addressed by Amazon, and Amazon came out with its own cloud storage or cloud data warehouses. Or there are a lot of services provided by Amazon. Okay, so data warehouse in Amazon is Redshift. This is just a name, a cool name given by Amazon, but it is a data warehouse. Then Snowflake came. Snowflake, which is actually right now, it's really a big thing. Okay, there are basically data engineering certificates that's going on with Snowflake. Every company is moving towards Snowflake, and I think in an year, or not also an year, but soon Snowflake will take over all the traditional RDBMS and these data warehouses, because itself it is a data warehouse, but it is on cloud. Okay, so the thing is, the benefit of being on cloud is that you don't have to worry about infrastructure. Infrastructure is provided by the Amazon, or this Azure is a product of Microsoft. There's another product. Can anyone tell me which? How many? There are basically a lot of you know uh, cloud service providers. Okay, Alibaba is there. IBM also provides its own cloud, but the three giants are there. Two I have already mentioned here: Amazon and Microsoft. Snowflake is different. Okay, okay, it is data warehouse only. Okay, it is not a cloud service provider. It is cloud data warehouse, modern data warehouse. Okay, so Amazon is there, Windows is there. The third one, can anyone tell me what is the third one? Which company has the biggest? It's really in the talks also. No one? No one knows. It's GCP. Google. Google Cloud Platform. GCP is the one that is in news right now, and it's the current data provider. Okay, so the problem storage, the problem of velocity, variety of data, and veracity, quality of data. All these were as they came, all these were solved. But still, the problem is there because the data is growing and growing and growing. So the thing is that as the data will reach the exabyte stage, we'll have something new to deal with it. Okay, so any questions till now? Yeah. Any questions from? Are you getting what I'm talking about, or it's just going over the head? I seriously, you'll have to interact with me, guys. Yes,
So
no,
my question is, what we are going to learn and the map of our like syllabus.
yes, syllabus. So right now I'm just giving an overview of things that is happening here. Okay, how the system came. What we'll be learning is we'll be learning Hadoop. We'll be learning Scoop, that is used to get the data from SQL to Hadoop. Okay, how to process the data in Hadoop and get the results. Okay, for example, you use MySQL to query the data, but we will be using Hive to query the data, and then we'll be learning Spark. Spark is in-memory processing unit, which is faster in processing the data than traditional MapReduce. MapReduce is the programming model of Hadoop. I'll in the end I'll give you an overview of all the course structure that we'll be following. Okay, all the topics that we will be going through. Regarding what I have taught you right now, is there a problem, or is there something that you didn't understand? The problems that we are facing with big data, the storage, processing, everything is good. Understanding or not?
Yes, understanding.
It's pretty simple, right? It's not that difficult to understand. Okay, now let us come to the giant that we are here for in today's class is Hadoop. What is Hadoop? Hadoop basically came in picture in 2002. Started as Apache Nudge project. Okay, what was the duck cutting and Mike Caffarella? These two guys, what they were doing is they were designing web crawlers. Web crawlers are for websites. You type something on Google really fast, right? And it gives you results within seconds. So how does it do that? Because Google has indexed the websites. So duck cutting and Mike Caffarella, these two guys were actually trying to make web crawlers for indexing websites in 2002, but they had a problem. The problem is that the cost of indexing was getting really high. For 1 billion web pages, it was taking about over $5,000 to maintain the infrastructure, the processing unit, the electricity, and everything. The cost was too high. So what they were looking for was an efficient solution. Okay, so the thing is that in 2003, Google published a white paper called GFS, that is Google File System. This system, what it did is basically it divided the data into different different machines. For example, we have let's say we have 100 or 1,000 MB of data. Now, to store 1,000 MB of data, we would need a lot of storage in this. Okay, so what Google File System did is that made, let's say it made 4. There are 4 machines, 4 different storage. Okay, so what Google file system did is that it divided this 1000 MB into 4 small parts and stored it on the 4 machines. So we don't need a high storage here. So the thing is, this is called horizontal scaling, because the system in whole is formed in a cluster. Okay, and these clusters, these systems store chunks of data. So the problem of storage was solved with this Google file system. So half of the problem was just solved by Google for these two. After that, Google released another paper called MapReduce. What MapReduce did is that it basically made the, if we write a select query here for getting the result out of these chunks. Okay, if we have a single unit, what will happen is that this whole 1000 MB of data will be processed by one machine. But if we use MapReduce, what is that? This chunk will be processed by this machine only. This chunk will be processed by this machine. So the thing is that we are getting the results parallelly. All of these machines are operating at the same time and giving back the results within the same time frame as this single machine was doing. So the processing also became faster. So the other problem also was solved. Okay, and then what Mike Cafarella and then what Doug Cutting did is that he started working on this, started implementing it into a project called Nutch. After that, he gave Nutch the name Hadoop because his son was it's a history, we don't need to know that, it's just good to know knowledge. Okay, his son was the one who came up with the name Hadoop and not him. Okay, so this is Hadoop, how Hadoop is distributing the data, and with that distribution it is processing the data. Okay, so enough with the theory. Okay, let's take a like it's 1 hour, so let's take a quick break of 5 minutes. Okay, give me 5 minutes and then we will come in the architecture of how Hadoop actually works. Okay, everybody good?
Yeah, it is fine.
Yeah.
No problem.
Yeah, okay.
Thank you, brothers.
Yeah, yeah.
জুমের কিছুই বলেনি, ওই খালি ডাউনলোড করতে বলছে, অ্যাকাউন্ট করতে বলছে। ওইরকমই হবে, ওরা যে লিঙ্কটা দিবে ওখানে ঢোকার সময় যে পাসওয়ার্ড চাইবে, পাসওয়ার্ডটা হবে ওই ডেটের পাসওয়ার্ড। আর তোমার নাম দিয়ে ইয়ে করা হয়েছে, ওই নামটা ওখানে শো করবে তখন ওখান থেকে
ওখান থেকে কি আসছে একটা পাসওয়ার্ড হ্যাজ বিন চেঞ্জড।
হোক। আমার পাসওয়ার্ড ওখানে পাসওয়ার্ড তোমার যদিও লাগবে না, এই পাসওয়ার্ড ওখানে পাসওয়ার্ড দিয়েই অ্যাকাউন্টটা করছি হলো মাসুদার এম বড় হাতের, হোসাইনের এইচ, তারপরে তোমার ফোন নাম্বার।
কোনটা দেখে
Hello,
জুমে আসছিল?
everyone's here.
Yes.
Yes, we are
Yes.
hearing.
So now we look at the concept of virtualization. What is virtualization? Is that we actually in companies, when we work with big data, we work in Linux operating system. So why are we using Linux and not Windows? There are a couple of reasons. For example, let me clear this. Linux in operating system that is open source. For Windows, we have to buy a license and we have to only use the features that they provide. But Linux, being open source, what it does is that it is created by people, and anyone can take the source code and they can change the source code and they can make the operating system better. Okay, for being open source, it provides a lot more features than Windows. So the thing is, tomorrow you will actually get this Ubuntu machine that I've created. This is a virtual machine. Tomorrow we'll actually discuss and we'll see all the how this is going to work for you. Okay, I'm gonna provide you with this will be like on Google Drive or Dropbox or whatever it is. Okay, so I'm gonna provide a software also. This is VirtualBox, which helps us create the virtual machine. Okay,
But we
we'll
are
be
not
working
seeing
on
your
this.
screen.
Yes.
We are not seeing your screen. Can you share
Sorry.
this screen, please?
Sorry.
No problem. Thanks.
Okay. Here. Yeah. So
Thank you.
I will start again. Okay. So this is basically a virtual machine. What we do is that on Windows environment, we create a virtual machine. Now, virtual machine is, it uses all the hardware, like I have provided the RAM, how many processors it will use, okay, what is the capacity of storage we'll be giving, the audio, and how it will use my internet on this, and different configurations. We provide these configurations and we make a Linux operating system that is running on top of Windows. Okay, that's how we create a virtual machine. Now, why are we using Linux? Is, as I told you, it's open source. Plus, the thing is that we will be learning Hadoop, right? Hadoop you cannot install on Windows. Hadoop is only available on Linux systems. Spark that we'll be learning. Okay, Hadoop ecosystem has all the tools like Scoop, Hive, which we'll be learning. So all these systems can run only on Linux and not on Windows. And Spark can run on Windows, but the thing is that Spark itself uses HDFS, which cannot be installed on Windows. So for everything, we'll be using Ubuntu only. You might have heard of Ubuntu, right? Everyone has heard of Ubuntu or not?
No, we don't have much about a glance on.
No. Just that we have different kind of operating systems, like Windows is there, Mac is there, okay, and Linux is there. So Ubuntu is one of the flavor of Linux. Okay, and we'll be learning MySQL here only. You can practice MySQL. So here we have the MySQL that we used to practice in Windows, but we will be using Linux only. I've installed each and every software that is needed, from Hadoop to Spark to everything. Okay, I'll be giving this link to Adam, and he'll tell you, he'll share it with you. So by tomorrow, we will actually run each and every system, this machine on your systems. Okay, and we'll see that we don't have a problem with any of the systems that we are using, right? So the installation and not installation for you. I've already completed everything. So tomorrow will be a class on basically how to use your virtual machine and how to use Hadoop environment on that and MySQL environment on that. Okay, so giving an overview of all the things that we will be learning, right? Uh, okay, someone asked me about the question that what are we going to learn exactly? So I know it's really intriguing to get into the coding and you have learned Python and MySQL, but the thing is that having an overview of what big data is as important as learning how to solve problems from big data. That's why I was going through this theoretical session today, because we need to understand that what is the background of big data that we are dealing with. Okay, so tomorrow I'm planning of doing the virtual machine installation and overview of Hadoop architecture, how Hadoop works. Because the thing is that in interviews, you will get technical questions like, yeah, this is the query, this is the solving thing. But someone gives you a scenario based question, for example, that I have a cluster of 3 machines having these many cores and these many RAMs. And this is the amount of data. For example, I have 8 GB of data. For example, he gave a scenario of 8 GB. So how much time it will take? You don't have a problem here. You don't know what is the records that you are provided with. Okay, you just have a question that this these many nodes are present, and these are the configurations of all these nodes, and this is the data, and I want to get the result. How fast will I get the result? Now, without knowing the architecture, how can you solve that problem? Without knowing how Hadoop works, okay? See, solving a big data problem is not about just coding, like solving a Python program. Okay, you have a Python program, you solve that, you give the answer. But in big data, the cluster management is as important as writing the code, because you need to know how to distribute your data. You need to know how the architecture of Hadoop works, how the data is divided into different chunks, how the code that you have written is brought over to these chunks, and the data is processed and the result is brought back. If you don't understand this whole pipeline, you are not going to get far in the interview, because architectural questions are asked much more than, you're giving that, okay, these are the two tables, and I want to find out the result from joining these two tables. People only ask that how many kinds of joins, what are the types of joins you have. Okay, just knowing the types of joins and performing SQL queries is not going to get you a good big data job. Okay, we are going to be data engineers in our companies, and data engineers are expected to know theoretical aspects as well as the query solving capabilities. It's just not about coding. Okay, so this theoretical session is as important as learning how to make tables and learning how to join tables. Okay, the coding part will come, but we need to understand the background also. So today I'm giving you this overview because this overview is going to help you to understand all these things. Okay, and then we will come on to the commands, how we write HDFS commands. That is important because this is a distributed environment, right? For example, I'll give you a little thing. Okay, we start dfs.sh. This is how we start this services of Hadoop. Okay, we need to start the service and then only we can run. I could have written a shell file, and I could have made this automatic start as the machine starts automatically, but I am writing this so that you need to know that what services you have to start so that you can work in Hadoop environment. Okay, for example, we have this, and now should so here is the thing that we have a data node here. What are these? We'll learn. Okay, okay. The thing is that there's let's say a file residing on your system, on your local file system here, but it is not on this environment. You have to put that file on your local system to your Hadoop environment. For that, we need all these HDFS commands. Okay, to get the data from our Hadoop file system. For example, there is a folder in this, there is a folder, there is a file in this. How do you get the file from Hadoop environment to my local home folder? For example, let's say desktop. I want to get this word count, this file into my Hadoop environment. Okay. Okay, this is residing on my desktop here. There is no file in this. User Hussain, and now I put this file in here. Okay, because if I want to work with Hadoop, I need the file in my Hadoop environment and not on my local system. Okay, so this is just one example of what we are going to learn, but there are a lot more commands and very powerful commands that you can use to actually work with Hadoop. So these are called Hadoop distributed file system commands. Okay, then we'll have an overview of MapReduce programming model. Now, what MapReduce programming model is that on Hadoop the data is distributed in chunks. So to get the result, we have to send the code to those chunks, and then we have to derive the result, and then get that result back to a final output that we want. Okay, that is how MapReduce works. Because writing a common Python program is not how we can perform. Let's say we are from MySQL, so queries. Okay, it's not how we write a code and get the result from a data that is residing in HDFS. We need MapReduce model for that. Okay, but the thing is that MapReduce is old programming model. We, in today's world, we use Spark for that. What is Spark? How it is better than MapReduce? Okay, we'll learn all those things when the Spark topic comes. After that, we'll be learning Scoop. Okay, what is Scoop? So the thing is that we have a HDFS, but what if someone tells you that my company's data is stored in MySQL database, and now I want to move to Hive. Hive is query tool for Hadoop. Now I want to process my data with Hive only. I don't want to use MySQL. So what are you going to do? So Scoop is basically an abbreviation created, or not an abbreviation, but a short form of SQL and Hadoop. So you have SQL and you have Hadoop. So if you put it together, they made it Scoop. What Scoop does is that it brings the data from traditional these database management systems to HDFS, and with that we can use the Hive query tool or MapReduce or Spark to get the data to process the data. So this is basically used to get the data from
প্রিয়া ঠিক আছে না?
uh, DBMS
ক্যামেরা
to
মাইক্রোফোন
অবশ্য
distributed file
এটার
system,
সাথে
Hadoop.
কালকে সকালে
Then
কথা
we will
বলছিলাম
learn Hive.
কম্পিউটার সাথে।
কেমন করে কথা বলবো?
What is Hive? Basically, it is a query tool
তোমার ওখানে
that is used
ইউজার
to
আইডি আছে
process the
পাসওয়ার্ড আছে,
data
ওইটা এখান
that
থেকে ইয়ে
that
করলে
is stored in
জাস্ট
HDFS.
ওখান থেকে এখানে কথা
For
বলা যাবে
example,
ইয়া দিয়ে জুম দিয়ে কথা বলবো,
just showed you this data, right?
সেটাই কালকে টেস্ট করবো আর কি।
Okay, how many times do I have RAM in
তো ওটার
this?
এমনি
How many times do I
ইউজ
have
করে
SAF in this? From
ওই
looking
ইনস্টল
at this,
করার
we can say
সময়
2,
ওখানে
right?
ছিল
And
টেস্ট
RAM
করার
is 3.
অপশন।
কিংবা
But
স্কাইপ
we have to write a code. You have written Python codes, right? To separate these lines
না না
and then split these
ওগুলো
lines
টিভি
with
সবই
these
দেখছি,
and then
তুমি
count
মেসেঞ্জার,
these.
হ্যাঁ মেসেঞ্জার কল দেওয়া হবে।
Okay, three things.
দাও।
First, we have to
হ্যাঁ তুমি
segregate
দাও,
all the
আমি
lines.
মেসেঞ্জারে কল দিই, তুমি ওখানে
Second, we have to use a split method and split it.
আমার কোথায়?
And third, we have to count each and every
কাজ করো
instance.
এখন থেকে।
And then what we have to do, we have to gather the, like, there are 2 self in this, there are 0 self in this, there are 0 self in this. So 2 plus 0, that is 2. So we have 2 as a result. For that, we can write a Hive query also, which we will be learning. What are the data types? Like in MySQL, there are data int, varchar, you might have learned. So those are the data types. How do we write the queries? How do we make tables? How do we write Hive functions also? And then there is a concept of partitioning and bucketing. This is really important, powerful too. What we do is that we have TBs of data, okay? But the thing is that in Hadoop also, in HDFS also, it is storing the data in blocks. Okay, the blocks are just created. For example, as we learn that each block is of 128 MB. So there is a 1 GB file. You divide it by 128 MB. That becomes 8 parts, right? So it will store the file in 8 parts. Now this is not stored efficiently, right? Because if I want to get the data that resides only in 2 parts, still I have to go through all the 8 parts of those. So if I go through all the 8 parts of those, then it will be inefficient for me, because the data is residing only in 2 parts and I should process only those 2 parts. So that's how we use the partitioning concept, and we partition the data according to our needs so that the processing is faster. Bucketing is same, but it is better. In some cases, it's better than partitioning. Then as we have the joins, we have views, joins, indexes, and then these are the user defined functions. For example, if you have heard of stored procedures in MySQL, anyone has heard of stored procedure in MySQL? Yes,
No.
no,
No.
no. So in MySQL we have stored procedures. Same thing we have Hive in UDF. We learn now what stored procedures are when we are learning SQL. Okay, the transaction, the asset. Have you Adam has taught you about asset transactions in MySQL? The earlier trainer.
No,
What did you learn in MySQL?
just how to create a database.
That's it.
Yeah,
Okay.
that's the only thing we learned.
So you wrote the query, but okay, fine. You don't know the history of MySQL also. No, not the history, but ACID transaction is important. File compression is there, windowing functions. These are also window functions that we'll be using. Then there comes Spark. Okay. What is Spark is that it is in memory processing. What is in memory? What is on the hard disk? When we learn Hadoop architecture, we'll get to know what is in memory and what is like processing in on hard disks. And these are all the basic functional unit of Spark is RDDs. These are the transformations and actions. They're basically how we actually convert the data into meaningful things and get the results are done with these two things, transformations and actions. And then we have caching paired RDDs. These are all the programming things that we will learn. Okay, because everything in Spark is run on this RDD. When we learn the architecture of Spark, okay, and it is quite important. I'm saying it again, the architecture. Why? Because there are interview questions that the first question, define the architecture of Spark. This is asked frequently in companies. Okay, do you know the architecture of Spark, how architecture works? So this is not a programming question. You're not given a query here. You're not given how to find a prime number in Python. Okay, but if you don't give the answer of architecture, how the interviewer is going to ask you any other another question? So the thing is that learning these things, the theory, it's boring. I know that. Okay, but the thing is that it is as important as solving the problem. Okay, it's really intriguing to get into the coding and stuff, but theoretical aspects is the one that teaches how to use things practically. After getting into all the RDDs and the data frames, this is another API which is currently in use. RDD is the old API. Okay, but the thing is that as I told you, there is structured and there is unstructured data. So for unstructured data, you have to use earlier people were using RDDs, but the thing is that RDDs is quite tough to work with. Okay, so what is the solution they came up with is data frames. Data frames basically makes your data into a tabular format only, like the tables that you have in MySQL. Okay, so all those uh, data when stored in forms of rows and columns, it becomes easier to see and it becomes easier to process them. So that's how data frame came into existence. After learning data frame, we'll get into Kafka, which is real time. Kafka is real time. That means that, for example, your mobile devices, it is producing data, but it's producing data continuously 24/7. So that's what we call a real time data. Okay, how we process a real time data with structured streaming. That is a part of Spark, and the real time data is brought from Kafka. Okay, all these things are related to structured streaming only. And then again, an important interview topic, that is optimization. This is again also a theoretical concept, but there are a lot of use cases that are designed. Okay, so we'll learn about optimization also, how to optimize your code so that it can get you results faster. Deployment modules fine. Now these are integrations. How we can process the data in Spark and store it in MySQL. How we can process the data in Spark and store it in with the help of Hive. We can store it in HDFS. And this is also the data warehouse, the cloud data warehouse that is right now it's on the boom. That's Snowflake. We learn all the integration, and this is basically orchestration tool, Airflow. Okay, whatever we are creating, for example, a data is residing in MySQL. We are bringing it to HDFS. We are processing it with Spark. We are getting the result, and then we are storing it again in MySQL. Okay, all this is the whole pipeline that we have formed. So each and every stage that we can, with the help of Airflow, we can design this whole pipeline. It gives us, like for example, we have this GUI here, right? So Airflow also gives us a GUI which tells us how the which of the jobs that we have given is completed, which is pending, where an error occurred. Everything is shown in a GUI way with the help of Airflow. Okay, and then we'll have our final project. For example, I give you a small pipeline here, right, from MySQL to HDFS to Spark and this. So we'll create a whole project. Okay, data is residing somewhere. It comes. We'll have multiple sources of the data. Okay, then we'll process the data with Spark. Okay, and how we store that data in all of these three. Okay, we'll design a whole project on that. And then there will be a resume preparation and interview preparation. Okay, and as I was saying, just a second. Okay, just a second, let me get this. The reason why I'm getting all this theory to you. Where is that person? You can see my screen, right?
Yeah.
Hello?
Yeah.
Yeah. Okay, so what are we learning? Why are we going through these queries? So you have heard of this company, IBM? This is the question that was asked. What is asset
Yeah.
properties and explain its importance? This is the interview question. Now tell me, do you see a query here? Do you see a program here? What is indexing in Hive? Okay. What are partitions and bucketing? These are the questions this is the question asked in what are SCB type 1 scenarios? Have you worked on SCB type 1 scenarios? Where will you see logs in Hive? As intriguing querying and learning programming and writing code is, but the thing is, let's say not 90, let's not go, but 70% of the questions that are asked are about the architecture. Hive thrift server was asked, what is Scoop internal process? How Scoop actually brings the data from MySQL to your HDFS. This is the internal process. As I was saying, we will be learning Airflow. This is Oozie. This is based on Hadoop, but it is an old tool. Okay. When we will prepare the resume, if we have not mentioned Oozie in our resume, no one is going to ask you questions about Oozie. Don't worry about it. Okay. If you have 200 tables, how will you import expert 3? Except 3. This is a scoop question. I have 200 tables in my database. Okay, there are 3 tables that I don't want and 197 tables that I want. Now, there is no coding in here, right? You just have to know one command, which we'll be learning as part of our roadmap, which I've shown. This scoop commands. These are the commands that we'll be learning. So in that we have just one except clause, and that will remove all those or include clause that will include all those tables that we want.
হ্যাঁ ওখানে যায়নি
So see, the
যেমন
thing
ধরেন
is that
দিয়েছে
why I'm teaching this
আচ্ছা
history
আচ্ছা
and why I'm telling you that we learn the
ওগুলো
architecture, we
শেখাচ্ছে
have to learn the
যায়
virtualization machine,
বিভিন্ন
is
জায়গায়
that
যায়
because these
ক্রেডিট
are the questions that are asked. Questions are asked on this VM also, because the thing is that we have to, as part of our job, we have to write these codes. These are not
সব ধর্মেরই
programming
ভেজ
codes,
আছে
but
কিন্তু
command line codes.
হিন্দু ধর্মের কোনো ভেজ নাই
We need these,
একটা
we
বড়
need to
পাহাড়
know
দেখছে
why
মনে
do
করছে
we
এটাই
write
দেবতা
SDFS, DFS, and what are these options. We need to learn a lot of more
It
options,
doesn't
as
make
then with time
sense.
we
আমি
learn them.
বলতেছি ওরা বড় ট্রি দেখলে মনে করে এটা আমার
Okay,
বাড়ি,
so today's
ছাগল
orientation
দেখলে
class
মনে
was
করে এটা আমার
just to
ঠিকই
jog up
বলছেন
your
একটা
memory
বাচ্চা বুঝতে
and to
পারতেছে
tell
it
you
দেন।
doesn't make
that,
sense
be patient with the code.
ওরা ডল বানায়, ডল
Okay,
বানায়
we learn how
বাড়িতে
to code,
রাখে
we
দেখে
learn how to
আমার
create
ঘর।
databases and
It doesn't
tables and
make
joining and
sense.
coding and everything, but we have to prepare ourselves for interview purpose also, not just learn how to code. Okay, because the questions are asked more on architecture and your command line commands than they are asked of solving a business problem. Okay, obviously we will learn how to solve a business problem, we will learn how to join the data, we'll also learn how to get the results out of those queries, but theory is as important as coding. Okay, we're good.
Yes, good.
Let's not stretch this because this is actually, there was too much theory today, so people are a little bored. I get that. So let's end the session today with just one more boring topic that I have, but that is kind of uh, because I got this interview questions, I just remembered this. It was a good thing. Okay, so the thing is what is cap theorem? We have another theoretical concept, and that is cap theorem. Sometimes there's a direct question of, see, it depends on how technically sound your interviewer is. Okay, if he is your tech lead is taking your interview, your project manager is taking your interview, he might, or there's a good chance that he'll ask about cap theorem. Okay, when as I said that the big data is a distributed data. Okay, so with distribution there are a few challenges, because we are dividing the data into different storage systems. Like we have 5 different computers with 5 different hard disks physically in 5 different computer cabinets, right? We have a PC, we have a cabinet, so we are joining 5 different cabinets. Now the data is residing, some data is residing on 1, some on 2, some on 3. Let me get this again. This is 1, 2, 3, 4. Okay, some data is residing on, here is 100 MB data residing. What is happening here?
কাজ করতেছে
100 MB is here,
একা একাই বলতেছে একা একা
100 MB is here, and 100 MB is here. Now what happens if the power in this goes? I'm processing the data. Okay, but if the data that is residing in this machine is not available to me, then will my result be proper? No, because I don't have the data that is required to get the result of all 400 MBs. I only have the data of 300 MB. So there comes a problem of availability. The C stands for consistency. Now I need to have the data consistently with all the processing units. Like for example, I have these 400 MB of data, but it is not necessary that I'm running only just one query on this 400 MB. I can be running 5 queries or 10 queries or any number of queries. Okay, so the thing is, consistency means that every every program that I send should have this data as the first, and as the first program is seeing, and as the last program or query that I've given. Okay, so consistency is also important. There's a problem with consistency also, that the data should be consistently available with each and every uh, uh, program or query that I send to get the result. Okay, and then there's a concept of partition tolerance. What do you mean by partition tolerance? For example, as I said that here one of the node is not available. So what should it do? It should just stop the query, because we are only getting 300 MB of data and this is not available. So the query, if processed, will be processed on only 300 MB and not 400 MB. So we don't have a complete data. So should the query stop or should it continue running? This is called partition tolerance. The system should work even if the data, even if one of the node is failing. Okay, so whenever this node will be again available, it will include the data from this. It will merge the data from whatever the result is gotten here, and it will produce a final result. So that is called partition tolerance.
সকালেই
Because
চা বানিয়ে
the thing is that the data which we process are in TBs. Okay, if we stop the query for every single node down, we are having 200 nodes, we are having 1000 nodes. Okay, tomorrow when we learn the Hadoop architecture, I'll tell you how Yahoo actually used Hadoop and processed the data of connecting 1000 nodes, and gave the result very faster. Okay, how Yahoo actually incorporated Hadoop to solve the big data problem that it had. Okay, so the thing is that there are 1000 nodes. Now if one node is down, do you want the 999 nodes to stop working? No. Whenever the data from that particular node is available, it will be incorporated and the final result will be given. But we don't want the other nodes to stop querying the data. Okay, so that is called partition tolerance. Now the thing is that with the cap theorem, okay, only two things can be achieved at a single time. Either it may be CA or AP or CP. For example, the cap theorem says that consistency, availability, and partition tolerance, these three things are important. But at a time, a system can only achieve two of it. All those tools, like for example, HDFS is defined, so it can achieve consistency and partition tolerance. Okay, another system can achieve consistency and availability. Another system can achieve, the design systems can achieve availability and partition, but all three are not possible. There are no system designed that can achieve all three of these. Okay, for that Any questions?
No.
No? You good? Okay,
Yes.
so let's end today's class with this note. Tomorrow you'll have machine, and you'll need to install this VirtualBox software also. So you will by the like here it will be end of the day, but your will be morning. So by morning you'll get the downloads. Okay, just download it and keep it at in your system at some place wherever you feel comfortable. Okay, and in tomorrow's class we will actually install this, and I would need one of you to share your screen so that I can guide you how to install, and others also looking at that person install these in your systems, because we will be learning SQL in obviously MySQL. So we'll be querying here only. Okay, we are not using Workbench because we don't actually work on workbenches. We are not SQL developers. We are data engineers. Okay, so data engineers, basically in your system you won't be working on this my MySQL workbench. You'll be working on your this only. This is called a terminal. Okay, you'll be working on it when we'll discuss Linux tomorrow. Oh no, in the next session. Sorry, day after tomorrow, not tomorrow. In the next session, when we'll discuss Linux, I'll tell you what terminal is, what shell is, how we write the commands, and how this whole Linux understands what's going on in here. Okay,
So
so
which days are we having class?
today is Monday, right? We'll be having next class on
I
Wednesday,
think only Wednesday, right?
and then the next will be on Friday. So Friday is your SQL class. Okay?
That means it's Monday, Wednesday, and Friday, right?
Yeah, Monday, Wednesday, and Friday.
Also, not Tuesday anymore, right?
No.
No. See, there might be weeks in which I may change this, like it will be Tuesday, Thursday, and Saturday. Okay, according to, because I also have to balance my work also.
Okay,
Okay,
sure.
so if I have an early meeting in the morning, but I will inform 1 week before that in next week we'll be having the class on these days. Okay.
Okay,
So don't
thank you
worry.
very much.
I'm not going to tell on Monday that we don't have a class today and we'll have a class tomorrow.
No, it's
No,
okay.
in advance in 1 week I'll tell you that in next week the shuffle will be there, like that. Okay, so
Okay.
any enough with this theoretical sessions. Tomorrow we'll get our hands dirty and we'll write our first Hadoop code. Okay, now this last thing, sorry. Hadoop code is written on Java and not on Python. Okay, we don't write Hadoop codes on Python because Hadoop was designed in Java. Okay, it's not that we cannot write, but the thing is, this MapReduce model was basically the model was developed in Java, and you won't find people writing Python code into Hadoop. And don't worry, this is just one program that I'll be showing to count the numbers. This is called a word count. The file name is also word count, and the program is also called word count. Okay, this is just to make you understand how MapReduce model works. No one is actually programming in today's world, in right now, in any company. People are not writing MapReduce codes. The reason I'll tell you why it is, but the thing is, when we learn the MapReduce model, I'll tell you why it is. Okay, so
Okay.
the thing is, tomorrow we'll write a Java code. Okay, but it's just for your understanding. You don't need to get so worried that I've not used Java, how am I going to write that program. It's not a problem. Okay, so let's get going. Okay, I hope it was not too boring and no one is actually sleeping.
No.
Yeah.
No one's sleeping.
And yeah, please, if you feel anything like like there's something you don't understand with my accent, or I'm speaking too fast and you're not getting, please, we have a WhatsApp group also, and here in the session also you can tell me. Okay, anything,
No problem.
because
Thank you.
learning is important. Okay, and for you understanding is more important than me teaching.
Yes, exactly.
Yeah.
So
Good.
if you
Definitely.
have some problem, no problem. We'll ask you.
Okay, and interview preparation also. So I'll include okay, we have an understanding that I don't need to include this SQL every week, right? And every week the third class is of SQL. Okay. See you tomorrow.
Yes, thank you very much.
Yeah.
Have a
Yeah.
great day.
Yeah. Thank you.
Thank you, Brother Hussain.
Yeah.
Thank you so much.
Yeah. Good night. Good night.
Good night.
Good night. Bye.
Thank you. Bye. Allah Hafiz. Assalamu alaikum.
Allah Hafiz.
Recording stopped.
Yeah. Adam, you there?
হুসাইন ব্রাদার হুসাইন বলতেছে আমার হিন্দুর নাম হুসাইন
কে
আলী।
brother হুসাইন?
আমাদের টিচারের নাম হলো হুসাইন।
তো brother হুসাইন কে বললো তোমাকে?
নাম হুসাইন না
তো
মানে
রিগাল নাকি ওদের দেখলাম।
হুসাইন রিগাল। হ্যাঁ
রিগাল আবার কোন নাম হয় আমি শুনলাম না। রিগাল মানুষের নাম হয়।
দেখো প্রথমে আমি সালাম দিছি, ও সালামের উত্তর দিলাম। আবার সালামের তো আলম না কি যেন একটা আছে নামের সাথে, মানে মুসলিম, এতে কোনো সন্দেহ নেই।
হুসাইন আলম